Okay, good day to everyone. So, ang i-discuss ko ngayon ay theorems on chords, arcs, central angles, and inscribed angles. Wherein, under this topic, you are going to prove theorems related to chords, arcs, central angles, and inscribed angles using two-column proof. And you are going to apply those theorems on chords, arcs, central angles, and inscribed angles on how to find the measure of the given arcs and angles of a circle. So to start with, under theorems on central angles, arcs, and chords, we have three theorems. So let's start with the theorem number 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So, we have circle E below, wherein in circle E, we have angle SET congruent to angle NEO. Because the two central angles of circle E have measures of 50 degrees, so they are congruent central angles of circle E. Since the two central angles are congruent, the minor arcs they intercept are also congruent. And what are the minor arcs that are congruent? So we have arc ST, the intercepted arc of central angle SET, and we have arc NO, the intercepted arc of central angle NEO. So we can say now that arc ST is congruent to arc NO. So in another figure, if circle E is congruent to circle I, and angle SET is congruent to angle NEO, congruent also to angle BIG. So if the three central angles of circle E and circle I are congruent, then we can say that their corresponding intercepted arcs are also congruent. And these are arc ST congruent to arc NO, also congruent to arc BG. So this is theorem number 1 on central angles and arcs. So if the two central angles are congruent, then their corresponding minor arcs are also congruent. Now, under the first theorem, the proof has two parts. Part 1, given are two congruent circles and a central angle from each circle which are congruent. So the two-column proof below shows that their corresponding intercepted arcs are congruent. So let us have the given figure. So we have circle E congruent to circle I. And in circle E, we have central angle SET. Then in circle I, we have central angle BIG. So we can say that angle SET is congruent to angle BIG, as illustrated in the given figure. So what you need to prove is arc ST is congruent to arc BG. Now let us have the two-column proof below, which is composed of the first column, the statements, and for the second column, the reasons. So laging ang number 1 na isusulat natin sa statement ay kung ano yung given information dun sa ating figure. So given naman that circle E is congruent to circle I, then central angle SET is congruent to angle BIG. Ang reason, given. So for number 2, as we can see in circle E, so we have the measure of central angle SET is equal to the measure of arc ST, the intercepted arc. Then in circle E, the measure of the central angle BIG is congruent or equal to the measure of arc BG. So what is the reason for this statement? The degree measure of a minor arc is the measure of the central angle which intercepts the arc. So that is the relations between the minor arc and the central angle which intercepts the arc. So they have equal measure. Now statement number 3. The measure of angle SET is equal to the measure of angle BIG. So for statement number 3, our reason is from statement number 1. So this is the definition of congruent angles. The number 4 statement. So we can say now that the measure of arc ST is equal to the measure of arc BG because as you can see in statement number 2 and 3, so we have the substitution method. So we substitute the measure of arc ST to the measure of angle SET, and then we substitute the measure of arc BG to the measure of angle BIG because it is already written in statement number 2 followed by statement number 3. So this is just by substitution. Now for number 5, we can say that arc ST is congruent to arc BG because it is supported by statement number 4, and the reason is the definition of congruent arcs. Now let us have the part 2 of this theorem number 1. So given are two congruent circles and intercepted arcs from each circle which are congruent. Now the two-column proof below shows that their corresponding angles are congruent. So what are the given? And what do we need to prove in this part 2? So given circle E congruent to circle I. Then arc ST congruent to arc BG. What we need to prove now is the central angle SET is congruent to central angle BIG. So angle naman ang ipoprove natin. Kung yung dalawang minor arc ay congruent, i-prove naman natin na yung central angle na nag-intercept dun sa minor arc na yun are also congruent. So again, the two-column proof here, we have the statement and reasons. For number 1, isulat uli natin yung given. We have circle E is congruent to circle I. And then arc ST congruent to arc BG. So, isulat ulit natin yung reason because this is already given. Yung number 2, so, tingnan ulit natin yung circle E. Meron siyang measure of arc ST is equal to the measure of angle SET. And then in circle I, measure of arc BG is congruent to the measure of angle BIG. So the reason that supports statement number 2 is the relationship between the minor arcs and the central angles which intercept the arc. And it states that the degree measure of the minor arc is the measure of the central angle which intercepts the arc. So whatever the measure of the intercepted arc, yun din yung measure ng central angle na nag-intercept sa arc na yun. Number 3 statement. the measure of arc ST is equal to the measure of arc BG. So it is supported by statement number 1, and this is the definition of congruent arcs. Now let's proceed to number 4 statement. The measure of angle SET is equal to the measure of angle BIG, supported by statement number 2 and statement number 3. So ano ang ginawa dun sa statement number 2 and statement number 3? So we apply the substitution because dun sa statement number 2, given doon, measure of arc ST is equal to the measure of angle SET. So, pwede natin i-substitute ngayon dun sa number 3, yung measure of ST, arc ST, papalitan natin ng measure of angle SET kasi nandun siya sa statement number 2. And then, is equal to the measure of arc BG. So, ang ipapalit naman natin dun sa measure ng arc BG ay yung nanggaling sa statement number 2, wherein the measure of arc BG will be substituted by the measure of angle BIG. So that's why in number 4, we have the measure of angle SET is equal to the measure of angle BIG. Now for number 5, kasi na-prove na natin that the measure of the two central angle is equal, for number 5, we can say now that angle SET is congruent to angle BIG. And it is supported by statement number 4, the definition of congruent angles. So, combining part 1 and part 2, the theorem is proven. So, let us now proceed to theorem number 2. For central angles and arcs and chords. So, what is theorem number 2? So, this is theorem number 2. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, kung yung minor arc nung dalawang congruent circle ay congruent, so pwede rin nating sabihin na yung corresponding chords nung dalawang circle ay also congruent. So, illustration niya, in circle T, on the right, we have line segment BA, so that is a chord. Congruent to line segment CH, another chord of circle T. So, the two chords of circle T are congruent. Then, we can say that arc BA is also congruent to arc CH. So, yun yung sinasabi ng theorem number 2. Kasi congruent yung dalawang chord, so yung corresponding arc nila ay congruent din. If circle T is congruent to circle N, so there is another circle, and the two circles are congruent, BA is congruent to CH, the two chord, congruent to the chord of circle N, which is chord OE. So, kung yung tatlong chords nung dalawang circle ay congruent, we can now say that arc BA is congruent to arc CH, also congruent to arc OE. So, congruent din yung kanilang corresponding minor arcs. So, that is for theorem number 2. So, again, for theorem number 2, meron ulit siyang part 1 and part 2. So, ipuprove natin using two-column again. So, here is part 1. So, in part 1, given two congruent circles, circle T congruent to circle N, and two congruent corresponding chords AB and OE. The two-column proof below shows that the corresponding minor arcs AB and arc OE are congruent. So, given circle T congruent to circle N, a line segment AB congruent to line segment OE. So those are the chords of circle T and circle N. They are also congruent. So what we need to prove is arc AB congruent to arc OE, their corresponding minor arc. So here is the two-column proof again. Statements and reasons. For number 1, kopyahin ulit natin yung given information as our first statement. So, ano yun? Circle T congruent to circle N, then line segment AB congruent to line segment OE. Reason again, ilagay natin, given siya. Number 2, we have line segment TA. So, ang gagawin natin dun sa first circle, i-connect natin yung center point ng circle, yung T, papunta dun sa A. So, magdodraw kayo ng radius. So, that is line segment TA. And then, magdodraw ka ng another radius from T to B. So, that is line segment TB. So, line segment TA congruent to line segment TB. Kasi nga, sabi doon sa reasons, number 2, radii of the same circle or of congruent circles are congruent. Kaya pwede natin idugsong to sa statement that this is also congruent to line segment NO congruent to line segment NE. So, ganun din ang gagawin natin. Bali, magdodraw kayo ng tig-dalawang radius dun sa circle T at dalawang radius dun sa circle N. Connecting N to E, connecting N to O, connecting T to A, connecting T to B. And those line segment are all congruent because the reason radii of the same circle or of congruent circles are congruent. Now, dahil doon sa ginawa nyo sa number 2, kung mapapansin nyo, kung nag-draw kayo sa inyong scratch paper, anong nangyari, nagkaroon kayo ng dalawang triangle. Triangle ang nabuo nyo sa circle T nung kinonect nyo yung T sa A at saka T sa B, nagkaroon kayo ng triangle A, T, B. And then, dun sa circle N, nung kinonect nyo yung N sa E at kinonect ninyo yung N sa O, nabuo nyo yung triangle O, N, E. So, for number 3, masasabi natin ngayon na triangle ATB is congruent to triangle ONE. Bakit? It will support by the reason SSS postulate. Kasi, tatlong side na yung na-prove natin doon sa statement number 1 at statement number 2 na congruent. Ano yung tatlong side na yon? Yung first side, yung chord AB at saka OE. That's the first side of the triangle ATB. And the remaining two sides that are congruent is yung TA at saka TB, NO at saka NE. So, yung tatlong sides nung nabuo yung triangle are congruent. That's why the reason for number 3 that the two triangle are congruent is supported by SSS postulate, side postulate. Okay, kasi from number 1 to number 2, dun nakalagay yung tatlong side na congruent. Now, statement number 4. Angle ATB. So, we have the central angle. So, we have angle ATB congruent to angle ONE. Reason? Corresponding parts of congruent triangles are congruent or CPCTC. Itong reason na ito ay gagamitin nyo lamang kung na-prove na ninyo na yung triangle ay congruent. Kaya ginamit natin siya for number 4. Kasi sa number 3, na-prove na natin na yung triangle ay congruent. And yung angle ATB at saka angle ONE, part siya noong triangle na prove natin sa number 3. That's why ang ilalagay nating reason kung bakit yung dalawang central angle na nandun sa triangle congruent ay congruent din, it is because that central angle is a corresponding part of congruent triangles. So, congruent din sila. That's why this is CP, CTC. Then, for number 5, arc AB is congruent to arc OE. So, ipoprove na natin yon. Final na answer na yun na yung pinuprove natin. Mapuprove na natin that arc AB is congruent to arc OE because, ang reason, from the previous theorem, in circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Kasi na-prove natin sa number 4 na yung central angles ay congruent. So, yung corresponding minor arc nila na AB at saka OE are also congruent. So, yun yung previous theorem natin and that is theorem number 1. In-apply natin sa theorem number 2. Naintindihan na. Now, let's proceed to part 2. So, ano yung part 2 niya? So, again, we have circle T congruent to circle N. And then, arc AB is congruent to arc OE. Okay, what we need to prove is line segment AB congruent to line segment OE. So, baliktad naman, ang ipuprove naman natin ngayon ay yung kanilang corresponding chord. Kung kanina, ibinigay yung corresponding chord ay congruent, ang prove natin kanina sa part 1 ay yung kanilang minor arc. Ngayon naman, ang given ay minor arc ang congruent, ipoprove natin yung kanyang corresponding chord ay also congruent. So, these are the statements and proofs, reasons for this two-column proof. Number 1, kopyahin ulit natin yung given. Circle T is congruent to ON. And then, arc AB is congruent to arc OE. Reason, syempre, given ulit. Number 2, the measure of arc AB is equal to the measure of arc OE. Sabi doon, ang reason, definition of congruent arc. Supported naman siya doon sa statement number 1. Number 3, angle BTA and angle ONE. So, kung susundan natin siya doon sa figure, BTA, angle ONE, those are central angles of circle T and circle N. That's why, ang reason, definition of central angles. Number 4, measure of angle BTA, the central angle of circle T, is equal to the measure of arc AB, the intercepted arc. Then, the measure of angle ONE is equal to the measure of arc OE. So, ang reason niya, syempre yung relation ng minor arc dun sa kanyang central angle na nag-intercept sa arc na yun. The degree measure of minor arc is the measure of the central angle which intercepts the arc. Now, let's proceed to number 5. The measure of angle BTA is equal to the measure of angle ONE. Siyempre, supported siya noong statement, kung mapapansin nyo, statement number 2, yung arc, at saka statement number 4. So, yung arc congruent dun sa central angle. So, ang ginawa, this is just by substitution. So, kung yung kanilang minor arc ay congruent, then yung kanilang central angle ay also congruent. So, this is just by substitution. Number 6. Line segment TA. So, ano naman yung line segment TA na yun? Radius na naman yun. T to A, that is a radius. Congruent to line segment TB, that's another radius of circle T. Congruent to line segment NO, radius naman siya ng circle N. Congruent to line segment NE, another radius ng circle N. Radii of the same circle or of congruent circle are congruent. Siyempre, pare-pareho lamang ang length ng mga radii ng circle or ng congruent circle. Doon sa number 6, kung mapapansin nyo, parang kagaya din kanina doon sa part 1, nakabuo ulit tayo ng triangle nung nag-draw kayo ng tig-dalawang radii doon sa circle T at saka sa circle N. So, ano yung triangle na nabuo? Statement number 7, we have triangle ATB congruent to triangle ONE. Ngayon, ang reason natin, hindi SSS, ang ginamit nating reason is SAS postulate, side, angle, side. Saan ang galing yung side, angle, side? Yung side niya, yung dalawang radii. And then, yung nasa gitna na angle, yung central angle BTA. So, yan ang nangyari. Yung dalawang side, yung common endpoint ng dalawang side, common endpoint nila is T, naabuo doon yung central angle na BTA, kaya meron tayong tinatawag na SAS postulate. Side BT, angle BTA, and side AT or TA. That's why this is SAS. Doon sa circle N, we have side NO, angle ONE, and then side NE. That's why that is supported by the reason SAS postulate. At saan yun nandun? Yung side ay nandun sa statement number 6, yung dalawang side, and then yung angle, yung included angle nila is nandun sa statement number 5. That's why we have SAS postulate for number 7. Since na-prove natin na yung dalawang triangle dun sa circle T na nabuo at saka sa circle N ay congruent, we can now prove that line segment AB and line segment OE are congruent. And sabi ko nga, pag na-prove na ninyo sa taas sa congruent yung triangle, since line segment AB and line segment OE is part of that two congruent triangle dun sa statement number 7, ang i-reason na natin dun ay corresponding parts of congruent triangles are congruent. So we have CPCTC na gagamitin nyo lamang kapag may na-prove na kayo na triangle sa taas na congruent. Okay? So tapos na tayo sa theorem number 2. Now, let's proceed to theorem number 3. So, yung theorem number 3, madali lang. So, kung makikita nyo sa figure, meron tayong diameter. Then, meron tayong chord. And then, meron tayong arc. Corresponding minor arc ng chord. Sabi dun sa theorem number 3, in a circle, a diameter bisect a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. Ano ba ibig sabihin ng bisects? So, pag sinabi natin bisects, dinivide niya yung segment o kaya ay yung arc into two equal parts. So, magkasing haba. Same lang yung length, same lang yung measure noong segment o nung arc kapag dinaanan siya ng diameter. Kung ang sinasabi ay a diameter bisects. So, it bisects if it divides the chord or the arcs equally. So in a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. So kailan mangyayari na it divides the chord and an arc equally? Mangyayari lang yon kapag yung diameter ay naging perpendicular dun sa chord. And pag sinabi natin naging perpendicular, alam naman natin na ang mabubuo dun ay right angles. So, kaya meron tayo doong symbol of right angle sa point I, the intersection of the chord and the diameter SE. So, in circle U, we have circle U. ES is a diameter and GN is a chord. If ES, so that is your diameter, is perpendicular to GN, that is the chord of circle. So, kung nag-form sila ng perpendicular lines, then we can say that GI is congruent to IN. And GE, arc GE, is congruent to arc EN. So, kung perpendicular yung nabuo, noong in-intersect ni SE yung chord GN, ibig sabihin, congruent yung mga segments noong chord na makikita mo dun sa chord at saka dun sa arc na dinaanan ng ating diameter. Okay? Pero kung hindi nag-form ng perpendicular line yung chord at saka yung diameter, we cannot say that the chords that intersect by line segment ES, and we cannot say that the arc that is intersected by diameter ES, hindi natin pwedeng sabihin na sila ay congruent kung hindi naman nag-form sila ng perpendicular lines. So, yun yung sinasabi ng theorem number 3. Now, so let's proceed naman sa next theorems. So, yung next theorems natin ay may kinalaman sa inscribed angles. Kung ang central angle ay angle kung saan ang vertex niya ay nasa center ng circle at ang sides niya ay yung dalawang radii, ang inscribed angles naman ay ang kanyang vertex ay nandun mismo sa circle at ang kanyang sides ay dalawang chords. So, kung makikita natin sa illustration, we have angle ACT. So, yan ang ating inscribed angle. Yung C nandun sa circle, tapos yung kanyang side na AC at saka CT ay chord ng circle. So, yan yung inscribed angles. So, under theorems on inscribed angles, meron tayong 4 na theorems. Iisa-isahin natin yan. Then, bibigay tayo ng mga examples kung paano i-apply yung theorems na yan sa pagkuha ng measure ng angle or ng arc ng isang circle. So, let's start with theorem number 1. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Okay. Yung inscribed angle, ang measure niya ay laging half ng measure ng intercepted arc. So, ibig sabihin yung ACT, kalahati lang siya ng measure ng arc AT. Or, pwede rin natin sabihin that the measure of intercepted arc, kung sa intercepted arc ka mag-i-start ng relationship ng dalawa, the measure of the intercepted arc is twice the measure of the inscribed angle. So, dodoblehin mo naman yung inscribed angle kung ang gusto mong malaman ay measure ng intercepted arc. So, ito na yung example sa figure natin. So, we have angle ACT, that is an inscribed angle. And arc AT is the intercepted arc of that central angle. If the measure of arc 80, so ang ibinigay ay arc 80, ang degree measure niya is 120 degrees. Then the measure of angle ACT is 1/2 of the measure of arc 80. So, ito na yung application noong theorem number 1 pagka kinuha mo siyang equation. So, inscribed angle si ACT, si AP ay intercepted arc. So, yung kanyang equation na mabubuo, the measure of the inscribed angle ACT is equal to 1/2 of the measure of arc 80. So, kung gusto mong malaman ang measure ng inscribed angle, what you need to do is get the half of the measure of its intercepted arc. Kaya yan yung ating equation. So, by substitution, let's find the measure of angle ACT, the inscribed angle. And this is equal to 1/2 of the measure of arc 80 given yung arc 80 which is 120. So, ano ang half ng 120? 60. And that is the measure of our central angle ACT. So, angle ACT is 60 degrees because the measure of its intercepted arc is 120 degrees. Madali lang, kahit hindi ka nga mag-solve. Pwede mo na agad sabihin ang measure ng kanyang inscribed angle. Basta kita mo or alam mo kung ano ang measure ng kanyang intercepted arc. Kunin mo lang yung kalahati. Okay na tayo dito. So, that's the application of theorem number 1, finding the measure of the angle of a circle. O, pwede rin naman ang kukunin mo ay measure ng arc. Just apply the equation formed by the first theorem. Now, let's proceed to another application of theorem number 1. So, this figure, we have the measure of PQR. So, that is another inscribed angle. Ibinigay ang measure ng inscribed angle PQR at ito ay 50 degrees. What is the measure of arc PR? So, ngayon naman ang hinahanap ay yung arc. Ano ang measure ng kanyang intercepted arc? So, kung alam mo na agad yung theorem, alam mo na kalahati yung inscribed angle. Yung inscribed angle, kalahati ng intercepted arc. And yung kanyang intercepted arc na yung hinahanap, ibinigay na nga yung measure ng inscribed angle. So, gamitin mo pa rin yung relationship. The measure of the inscribed angle PQR is equal to 1/2 of the measure of its intercepted arc. Then, mag-substitute ka. 50 is equal to 1/2 of the measure of arc PR. So, since you are solving for the measure of the intercepted arc or PR, properties of equality, we are going to apply multiplication property. So, magmumultiply tayo ng both side to get the measure of arc PR. So, 2 times 50, this is equal to 100. Common sense, 50 yung kanyang inscribed angle. So, yung kanyang intercepted arc is 100 degrees. Another one. Okay. If the measure of arc 80 is 130 degrees, so arc naman yung given, arc 80 is 130 degrees, find the measure of angle ACT. Same equation tayo, inscribed angle equals 1/2 of its intercepted arc. So, let us substitute, since ang hinahanap natin yung measure ng inscribed angle, so we need to get the half of the measure of its intercepted arc, which is 130. And its half is equal to 65 degrees. So, very easy lang si theorem number 1 for inscribed angle. Next. So, this is now theorem number 2. If two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. So, kung mapapansin nyo dun sa figure ko, meron tayong dalawang inscribed angle. And that two inscribed angle is PIO. Another inscribed angle is PLO. Pareho nilang in-intercept si arc PO. So, yun yung sinasabi sa theorem number 2. Two inscribed angle intercept congruent or same arcs. So, isa lang yung arc na in-intercept nila. So, we can say that, sabi doon, two angles in figure 1 below, PIO and angle PLO intercept arc PO. Since angle PIO and angle PLO intercept same arc, the two angles then are congruent. Siyempre, kasi yung kanilang intercepted arc ay congruent, same, congruent yung dalawang inscribed angle. So, paano siya i-apply? Ito na. If arc PO is equal to 98 degrees, so ibinigay ang measure ng intercepted arc PO, which is 98. Find the measure of A, angle PIO, and then B, angle PLO. So, solution. Kahit saan ka naman dyan pwede mag-start. Pwedeng mag-start ka sa B, pwedeng mag-start ka sa A, kasi pareho naman silang inscribed angle na nag-intercept dun sa arc PO. So, nag-start ako sa A. Measure of angle PIO is equal to 1/2 of the measure of PO. So, ina-apply ko yung theorem number 1, that the measure of inscribed angle is equal to 1/2 of the measure of its intercepted arc. And then, let's proceed to substitution. Measure of angle PIO is equal to 1/2 of the measure of arc PO. So, yung measure ng arc PO is 98. And half of 98 is 49. So, common sense, kung nakuha mo na si measure ng arc PIO, at ang sabi nga sa number 2 theorem, kung yung dalawang inscribed angle ay nag-intercept ng same arc, then they are also congruent. That's why in letter B, nilagay ko na doon, the measure of angle PIO is equal to the measure of angle PLO, kasi nga sila ay nag-intercept ng same arc. So, the measure of angle PLO is also equal to 49 degrees. Same lang. So, yun yung sinasabi ni theorem number 2. Next. So, ito naman yung theorem number 3. If an inscribed angle of a circle intercept a semicircle. So, ano ang semicircle? Siyempre, kalahati ng circle. At ang semicircle ay laging 180 degrees. Then, the angle is right angle. So, ano yung sinasabing right angle? Yung inscribed angle. Kagaya na nasa figure. So, we have angle NPE. That is an inscribed angle. Kung mapapansin mo, yung dalawang side niya nag-intersect dun sa N at saka nag-intersect dun sa E. Wherein yung N at saka E ay endpoint ng ating diameter. So, ibig sabihin, in-intercept niya ngayon ay semicircle. At alam naman natin sa theorem number 1 na ang inscribed angle is 1/2 of its intercepted arc. So, kung in-intercept niya ay semicircle, half of semicircle, which is 180 yun, half niya is 90 degrees. Kaya nga sabi doon, then the angle is a right angle. Kung yung iyong inscribed angle ay nag-intercept ng semicircle, then yung iyong inscribed angle ay right angle and it measures 90 degrees. Ayun, meron naman tayong label or symbol of a right angle dun sa angle P na ating inscribed angle. Yan na. Bigyan natin ng example. Given that AB is a diameter, what is the measure of angle corresponds to the value of x? So, yung figure natin na nasa baba. AB is a diameter, then what is the measure of or the value of x? So, kung mapapansin nyo, yung x dun sa figure natin sa baba, yung x na yon nagre-represent ng inscribed angle. At kung mapapansin din ninyo, yung ating inscribed angle nag-intercept ng semicircle kasi yung endpoint niya nandun sa intersection ng endpoint ng ating diameter. So, it intercept a semicircle. Meaning, the value of x is 90 degrees. So, x, which is our inscribed angle, is equal to 90 degrees because it intercept a semicircle. Ibig sabihin, right angle siya. So, yun yung sinasabi ng theorem number 3. Okay, now, Ito na yung pang-apat, which is the last theorem for an inscribed angle. Ayan. If a quadrilateral is inscribed, sabi mo quadrilateral, syempre yung quadrilateral ay may 4 sides yon. So, ayan na, sa figure natin, meron tayong nasa loob ng circle na quadrilateral. So, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So, ano yung opposite angles na tinatawag? Magkatapat na angle. At ano yung supplementary? Pag sinabi natin supplementary, pag pinagsama mo yung measure ng dalawa, equal sa 180 degrees. So, yung opposite angles, if you add, the sum is 180 degrees. So, that is what the statement means, that its opposite angle or angles are supplementary. So, kung makikita natin doon sa example sa figure, we have quadrilateral DREA is inscribed in circle M. That's quadrilateral. Now, ano yung opposite angles ng inscribed ng quadrilateral? So, the opposite angles of a quadrilateral are the following. So, we have RDA. O, tingin ka dun sa D, yun yung kanyang pinaka-vertex. Ang katapat noon is angle REA. So, ibig sabihin yung vertex niya, pag tinignan mo, D at saka E. Angle D and angle E are supplementary. That's why angle RDA plus the measure of angle REA is equal to 180 degrees. So, angle D plus angle E is equal to 180 degrees. They are opposite angles, that's why they are supplementary. Another opposite angle, angle DRA. Ang kanya naman ngayong vertex ay yung R. And then angle DAE. Ang vertex naman niya ngayon ay A. So, yung angle R at saka yung angle A, opposite angle sila. So, the sum of these two angles is equal to 180 degrees. So, madali lang. Basta i-add mo lang yung dalawang magkatapat na angle, opposite angle. Equal siya sa 180 degrees. So, yun lang yung i-apply natin sa pagsosolve ng measure ng angle o ng arc. So, tingnan natin yung example sa baba. Quadrilateral DEFG is inscribed in a circle. If angle D is 85, what is the measure of angle F? So, ano ba si angle D at ano ba si angle F? Si angle D at si angle F, they are opposite angles of a quadrilateral. So, pwede natin i-apply yung theorem number 4 para makuha natin ang measure ni angle F. So, ano yung magiging equation natin? I-apply natin. The sum of two opposite angle is equal to 180 degrees because they are supplementary. So, angle D plus angle F is equal to 180 degrees. Then, let us do the substitution. Given naman si angle D, 85 degrees plus the measure of angle F is equal to 180. Gamitan natin ng properties of equality. We have the subtraction property. The measure of angle F is equal to 180 degrees minus 85 degrees. Therefore, the measure of angle F is 95 degrees. 85 na kasi si angle D. So, para maging 180 siya, dun sa F, pag pinag-add, ang F mo ngayon is 95 degrees. So, the measure of angle F is 95 degrees. So, in-apply natin si theorem number 4 that the opposite angles, the sum of the opposite angle is 180 degrees. Okay, another one. So, magbigay pa tayo ng mga examples kung paano natin i-apply yung mga relationships na yan ng chords, arcs, central angles, and inscribed angles at yung mga theorems na yan. So, number 1, another example. Arc SR. So, we have arc SR is equal to 60 degrees. Arc yun ha. And then the measure of angle RST is equal to 40 degrees. What is angle RST? That is an inscribed angle. Sabi dyan, find the measure of arc ST. So, yung arc ST, yung malaking arc, yung major arc. So, kung ibinigay si arc SR at ibinigay si inscribed angle RST, how are you going to find the measure of arc ST? So, ganito ang ginawa natin. I-apply natin ngayon yung theorem number 1. The measure of an inscribed angle is 1/2 of the measure of its intercepted arc. Kasi given naman si inscribed angle. So, ang equation natin, the measure of angle RST is equal to 1/2 of the measure of arc TR. Yun yung kanyang intercepted arc. Then, isubstitute natin yung measure ng angle RST, which is 40, equals 1/2 of the measure of arc TR. Since may 1/2 na kasama yung arc TR, let us multiply both sides by 2. So, we can now find the measure of arc TR because if we multiply 2 by 40, the answer is 80 degrees. So, meron na tayong measure ng arc TR, 80. Meron na rin tayong measure ng arc SR kasi given yun, which is 60. Gamitan natin ngayon ng angle addition postulate do sa circle. Kasi pag inad natin lahat ng arcs ng circle, one complete rotation is equal to 360 degrees. So, meron tayong tatlong arc. Arc TR plus arc SR plus arc ST. If you add these three arcs of the circle, makes a complete rotation. This is equal to 360 degrees. By substitution, si arc TR nakuha natin kanina, we have 80 degrees plus arc SR given 60 degrees plus arc ST, which is the unknown, yung hinahanap nating measure ng arc. This is equal to 360 degrees. You just apply the properties of equality, combine similar terms. That's why we have 140 from 80 plus 60 plus arc ST is equal to 360 degrees. Subtraction property. Arc ST is equal to 360 degrees minus 140 degrees. So, ngayon, the measure of arc ST is equal to 220 degrees. So, anong in-apply natin dito? Yung first solution, in-apply natin yung theorem number 1. Inscribed angle is 1/2 of its intercepted arc. And then, to find the measure of the arc na hinahanap natin, in-apply natin yung angle sum addition postulate. Arc ST now is equal to 220 degrees. Basta alam natin yung mga relations ng arc, central angles, inscribed angles. Madali lang kuhanin ang measure ng arcs or ng angles ng circle. Another example, number 2. Okay, may quadrilateral na involved. The measure of angle GNM is equal to 108. So, that is angle N. And arc NM is equal to 44 degrees. So, tingnan lang natin yung figure. Given yung inscribed angle N, which is 108 degrees, and then arc NM, which is 44 degrees. So, find the measure of arc NG. Arc NG. Okay, tingnan natin yung figure. Arc NG is missing. Measure of arc NG. So, first solution, i-apply natin yung theorem number 1 ng inscribed angle. That inscribed angle is 1/2 of its intercepted arc since given ang measure ng inscribed angle, which is 108. So, our equation will be the measure of angle GNM is equal to 1/2 of the measure of GKM. By substitution, palitan natin yung measure ng inscribed angle. So, we have 108 degrees is equal to 1/2 of the measure of arc GKM. Since we need to find the measure of GKM, arc GKM, let's multiply both sides by 2. Now, the measure of arc GKM is equal to 216 degrees. So, kung alam na natin ngayon ang measure ni arc GKM, which is a major arc ng circle, GKM, 216 na siya. And given na kanina yung measure ng arc NM na 44 degrees, so ang remaining arc na lang natin na hindi natin alam kung ano ang measure ay arc NG. So, pwede na uli natin gamitin yung angle sum addition postulate. Because GKM, the major arc, plus another arc NM, plus the remaining arc NG makes a complete rotation again, and this is equal to 360 degrees. That's why nakabuo tayo ng another equation using angle sum addition postulate. So, palitan natin yung mga measures noong arcs na nandyan na. We already obtained the measure of arc GKM. Palitan natin ng 216 degrees. And then, yung given measure ng arc NM, which is 44 degrees, plus the unknown measure of the arc NG, yung hinahanap natin, is equal to 360 degrees. So, ganun uli, combine similar terms, apply the properties of equality to obtain the measure of arc NG. So, we have 216 plus 44 is 260. Plus arc NG is equal to 360 degrees. Now, use subtraction property. Arc NG is equal to 360 degrees minus 260 degrees. That's why we obtain that the measure of arc NG is equal to 100 degrees. So, ganyan siya gamitin. Next. In number 3, apply natin yung algebra. Find the measure of angle NML, wherein angle NML in the figure is an inscribed angle, which is represented by an algebraic expression as a measure of that inscribed angle. So, ang measure ng inscribed angle NML sa figure ay nirepresent ni 26x. So, yun ang dapat nating malaman. Ano ang ibig sabihin o ano yung measure na nagko-correspond dun sa 26x na yun kasi siya yung NML. And another one given is the measure of arc LN, which is also an algebraic expression. Arc LN is represented by 51x plus 3. So, that's the measure of arc LN. Again, the measure of angle NML is represented by 26x. That is our inscribed angle. And the measure of its intercepted arc LN is represented by 51x plus 3. So, let's apply theorem number 1. The measure of inscribed angle is equal to 1/2 of the measure of its intercepted arc. That's why we have the equation. The measure of angle NML is equal to 1/2 of the measure of arc LN. So, let us now substitute the given measure in the figure. So, the measure of angle NML is 26x and the measure of arc LN is 51x plus t. That's why our equation goes like this. 26x is equal to 1/2 times 51x plus 3. So, multiply tayo ng 2 both side para ma-simplify natin yung equation kasi mayroon tayong numerical coefficient na 1/2 dun sa right side. So, if we multiply both side by 2, magiging 52x kasi 2 times 26x is 52x. And then, multiplying the right side will gives us 51x plus 3 because 1/2 times 2 is already 1. Let us combine similar terms. So, 52x minus 51x is equal to 3 using subtraction property of equality. So, 51x if subtracted from 52x gives us x. Therefore, the value of x is 3. Since alam na natin ngayon kung ano yung value ng x, pwede na nating malaman kung ano ang measure ng angle NML by substitution. So the measure of the inscribed angle NML as represented by 26x, isa-substitute lang natin si 3 sa x. So meron tayo ngayon 26 times 3. Therefore, the measure of angle NML is equal to 78 degrees. So, ganyan yung applications ng mga theorems na diniscuss natin kanina. Theorems on chords, arcs, central angles, and theorems on inscribed angles. Idagdag pa natin yung application ng angle sum addition postulate. Okay. So, through the use of those theorems, you can now obtain the measure of the angles or the measure of the arcs of a given circle, whichever is unknown. Okay, good luck in answering your activity sheet. Sana masundan yung mga examples na ibinigay ko sa inyo. Pwede nyo paulit-uliting panoorin yung presentation na ito para ma-master nyo ang step-by-step or procedure on how you're going to solve for the unknown. Okay.